An object of mass 2 kilograms is taken from Earth, where the gravitational field strength is 10. So the weight would be 2 times 10, 20 newtons. But it's taken to the moon, where the gravitational field strength is much weaker. It's 1.6. So how do we do this? Well, the formula for weight is just F equals to ma, rearranged, or just like cosmetic tweak on it. Well, the force is the weight. You need to calculate that. The mass does not change. The acceleration due to gravity on the moon is much weaker. It's 1.6. And that's our answer. So the weight on Earth is 20. And the weight on the moon is 3.2. I'm very happy with the D being the answer. A rectangular gymnasium is 50 meters long, 25 meters wide, and 8 meters high. The density of air is 1.2 kilograms per meter cubed. What is the best estimate of the mass of air in the gymnasium? Well, the air in that gymnasium will occupy this much space. So what would be the mass of it, knowing its density? Well, let's first figure out the volume of that gymnasium, and we'll get the volume of the air in it. It's 50 times 25 times 8. And that comes out to 10,000 meter cubed. Now, if I want to figure out the mass, well, that's going to be the density formula rearrange, which is going to be rho for density and the volume. The density is 1.2 times 10,000. That's an easy math to do. I'll just get 12,000 kilograms. I'm happy with D being the answer. A sphere P made of steel has a weight of 10 newtons. Another sphere Q, also made of steel, has a weight of 10 newtons on Mars. The gravitational strength, field strength on Earth is greater than the gravitational strength on Mars. Okay. So this Mars pulls anything close to itself far weaker than Earth because its gravitational field strength is weaker, right? So if they're both pulling something, two different things at the same with the same force, so we know this is 1 kilogram because W equals to mg, so I know that's 1 kilogram. That's pretty straightforward because I know g approximated as 10. What can I say about the object Q, which has a weight of 10 newtons on Mars? So this is weaker. So heavier objects will end up having the same weight, if that makes sense. So this has to be the mass of Q is greater than 1 kilogram. I can figure that out at least. Let's see what the options are. Mass of sphere P is the same as the mass of Q. That's not true. They would have different weights then. Mass of sphere P is less than the mass of sphere Q. I think I'm happy with that, but let's read every other point as well. On Mars, the weight of sphere P is more than 10. Well, this is the lower mass, this is the higher mass. So on Mars, it'll actually be lighter, right? That's what we were talking about. Okay, sure. And if you're a little confused, what you can do is take a value less than 10, maybe 8 or 7 or 6 for the gravitational acceleration of Mars or field strength of Mars, and just calculate a hypothetical weight and just compare those values. So I'm happy with C being wrong, and I think we'll have D is wrong as well. On Earth, the weight of sphere Q is less than 10. I think same argument, right? It's just the reverse. So that's also wrong. So I'm happy with B being the answer. The mass of an empty flask is 34 grams. Okay. Volume of liquid is added to the flask of 20 centimeter cube. Okay. The total mass of the flask is now 50 grams. So how much liquid was added? So that's 6, 10, and 10. 26 was added. No, 16 was added. 16 grams was added, right? And so what's the density? So I don't think that's a difficult question. Density would be the total mass, which is 16. That's the mass of the liquid, and it occupies a space of 20. Now, at one point, you can reach for a calculator right now, but what's interesting is you know this fraction is less than 1. All of the options are greater than 1, aside from one of them. So, and it's a very simple question, so you probably don't have to get the accurate answer either. You just know. I think we all know A is the answer at this point without even calculating it further. Or you could do it mentally. A is the answer. A liquid has a volume of 0.04 meter cubed and a mass of 30,000 grams. So 30,000 grams, I'm looking at the options, they're all kilograms per meter cube. I want this in 30 kilograms. Okay. What is the density of the liquid? Well, density is just mass over the volume. The mass is 30 kilograms. Divide that by 0.04. The answer is 750 kilogram per meter cube. A measuring cylinder contains 40 centimeter cubes of water to begin with. A stone of mass 94 grams is lowered into the water so that it is fully submerged as shown. So you dip it, the water level rises exactly by the volume of the stone. Okay, so what's the new water level? It looks like it's 76. This is at 76 centimeter cube. So the initial was 40 centimeter cube. So what's the rise? The rise seems to be of 36 centimeter cube. So that's the volume of the stone that was added. So now I want to figure out the density, which is going to be the mass of this stone, which is 94. And I'm just double checking because all my answers are required to be in grams per centimeter cube. So I don't need to convert anything. Happy with this. Divide that by 36. I'm getting my answer as 2.6 grams per centimeter cube. D is the answer. Another easy question. We know the density, we know the volume, we need to figure out the mass. So let's do it directly. Mass is equal to the density times the volume. What is the density? It's 2.5 grams per centimeter cube. Multiply that by the volume, which we can find out directly here, which is 2 times 2 times 10, which is I think 40. 40 times 2.5 is 100, I think. Yeah. So our mass is 100 grams.